Alright YouTube, hello, thank you for watching. I've got an ozone generator here. I bought this to do a synthesis sometime in the future. And I think as an electronics engineer over the course of the years, being I played with a lot of high voltage in my life, I never really took it too seriously until I got this thing. This will pump out 500 milligrams per hour. Now 500 milligrams per hour didn't really seem like anything concerning to me, uh, but after having some respiratory issues, I've kind of changed my mind about that. The interesting thing about ozone, and I'm just a beginner idiot here, it has what some people refer to as a chlorine-like smell to it, although I don't really pick up on chlorine with it. It's extremely piercing. That's probably about the best I can put it. It's extremely piercing odor. You know, I played with high voltage for years, and I always knew about ozone, but never had an ozone generator. So the interesting thing about ozone is it's detectable down to zero point 0.1 parts per million, or a tenth of a part per million. Just to kind of put that into perspective with something off the top of my head, hydrogen bromide gas is detectable down to around 2 parts per million. So don't underestimate it. This was made for apparently a fish aquarium, and it works fairly well. I've had it running for a couple hours. It has not blown up, although I do anticipate that it's probably going to die when I try to do my synthesis with it, because it's such a long time for the reaction to take place. It has a timer that looks like it goes in 10-minute increments, which isn't going to be ideal for me because I'm going to need this thing to run for a very, very long time. But it does go up to 90 minutes before it reverts back to 1. So that's kind of one downfall here, but I mean, that's no big deal. I can make this thing constantly on if I want. I'll just have to get inside the guts to do it. The output level, you can hear it pulsing the high voltage. You can hear the frequency change. And I don't have ventilation here today right now. It's a pretty ugly day out, so I don't want to completely gas myself here. I was using this on a pipette, and I changed the pipette out. It comes with 2 stones. One is a round stone. I don't know technically what you would really call them. An aerator, perhaps, or a diffuser. Now this one here will fit through a 2440. There was some stuff on here that I had to chip off when it was made, but it fits through a 2440 joint. But I think the benefit to using the diffuser, we'll just call it that, is it's going to put a larger quantity of bubbles. So if you were trying to dissolve the ozone into something, you're probably going to get a higher ozone concentration being dissolved using the stone rather than shooting that into a pipette, because the bubbles are going to be very, very large. That's just my theory here. As far as the solubility of ozone goes, that's kind of up and down here. When you try to learn chemistry from the internet, you get a million answers, and sometimes I don't think that any of them's really right. But I've seen sources that say 109 milligrams per liter of water. That's pretty poor solubility in my book. I saw another source that said, strangely, 1 gram per 100 milliliters of H2O. And I'm not quite sure I believe that either. But I just wanted to pump the ozone into some water here just to see what would happen. Another thing too about ozone that's kind of interesting is ozone is more soluble in cold water than it is warmer water. So if you wanted to try to cram more ozone into the water, putting the water into an ice bath is going to get you a little bit more dissolved content to it. Now in theory, it seems like if circumstances were, shall we say, optimal, you should be able to produce hydrogen peroxide. But that doesn't appear to be the case. I'm not sure that proper bonding, for lack of better chemistry terms, really happens when you do that. And provided the solubility of ozone is so low in water, I mean, if you looked at it on a part per million scale, I mean, if 1 milligram in 1 liter of water is 1 part per million, if it was soluble at 109 milligrams per liter, that's basically only 109 parts per million that you could achieve, if I'm even looking at that right. So I don't know why, other than I don't think the bonding occurs between the ozone and the water to create hydrogen peroxide. The water does take on the ozone, and what I've witnessed is it has a pretty short half-life to it. Meaning you can pump a boatload of ozone into this, and it'll hold or retain some amount of that. But then as time goes by, the ozone just dissipates out of the water, and I think it reverts into oxygen. So the water won't technically hold the ozone, if I even put that right. What I did, just messing around, was I put like 100 milliliters of water in here, very, very clean, filtered pure water, and pumped some ozone into it for a couple hours. And then I took some low-level hydrogen peroxide test strips to see if I could get any indication, even the smallest of reaction, and simply couldn't get anything out of it. But that was not my intention of buying this ozone generator, but you know, in the interest of science, beginning chemistry, you got to try all stupid things. This seems like it may work. Like I said, hopefully it does not die after a very, very long extended run. What I liked about this ozone generator here is it came with an air dryer filled with silica to attach onto your air inlet line here to dry your air. I thought that was a neat thing, because if you try to buy these, they're like 30 or 40 bucks for one of these line dryers. So that made it pretty attractive to buy this. Now this is pretty noisy. You can kind of hear like a pump in it, like you would expect a small pump for an aquarium or something to sound like. But beyond the pump noise is the high voltage noise. Damn, that stinks like hell. Which is a little irritating to listen to. So I did that the other day with it, just to kind of get rid of the nuisance high voltage transformer oscillation in it. You know, if anyone wants to play around with ozone, I would definitely say if you're in a 350 square foot area, you know, you might want to think twice. If you have any respiratory problems like asthma or COPD, this ozone's probably going to hit you like a freight train. I thought it was something interesting to buy, to learn a little bit about chemistry, give it a go, and see what happens with my synthesis I want to do. Another thing here also, yeah, this is what I wanted to say, because this kind of caught me off guard here. I had some rubber line. In my expert opinion, I would say that this is EPDM rubber, from the pliability of it. Now look what happened to this rubber, whether you can believe this shit or not, because I almost can't believe it myself. Now that rubber had a hose clamp around it that was not overly tight, and the hose clamp was on there for just a short period of time, really. This is brand new tubing for all practical purposes. So I plugged this in the other day and I had no air coming out of it, and I thought, oh shit, the fan died or the pump died or what have you. And then I come to find out all the ozone was blowing out the hose. And I thought, how the hell can that be, really? Well, ozone, and this is kind of an old thing here when you get into rubbers. Sometimes rubber just doesn't take a lot of things. and apparently ozone tears this stuff up. Now the strange part is it's not supposed to degrade EPDM rubber. I did a little bit of research and it said if there's stress on the rubber, the ozone may attack it at a higher rate, which kind of makes sense to me. The cuts kind of coincide with where the hose clamp was, but how it got the big split, it just kind of blew open. It's always good when you're learning chemistry to study material properties and chemical compatibilities before you start working with stuff, because you just never know if your containers are going to hold up or if your hoses are going to hold up or what have you. Ozone and rubber, I'm saying, is a bad idea. So anyway, hey, I appreciate you taking the time to watch my video today. I know it wasn't very interesting, but we're going to keep on plugging away. So you take care and have a great day.